Now here on Kiwi. Let's stare into space with Dylan Storey. Thanks very much to the Auckland Stardome Observatory back this week. Good morning to you, Dylan.
Good morning.
And first up today, talking about a black hole that seems to be grazing on asteroids.
Yeah, this is one of these cool stories about black holes that rip things apart.
Yeah.
Like in the sci-fi stories, but this one's real. So, just a bit of background. At the centre of our galaxy, in fact, at the centre of most, if not all, galaxies, there is a special type of black hole that we call a supermassive black hole. So, you know, it's not just huge, it's supermassive.
Yeah.
And it's sort of it's pulling everything around it in with gravity, and lots of things are orbiting it. All the stars in the centre of the galaxy are essentially orbiting the black hole.
Right.
And it's been discovered by the Chandra X-ray satellite, looking at it in X-ray, in the X-ray part of the spectrum, that it flares occasionally. So the signal given off it in X-ray sort of flares up, and that can be between a few times and up to 100 times its regular output.
Huh.
So they're quite significant flares.
Yeah.
So the best theory on what could be doing this is that it could be eating asteroids.
It's hungry. It's eating asteroids.
It's hungry.
Okay. Yeah.
Black holes, by definition, are hungry.
Yeah.
They pull everything in and nothing gets out. So it's surmised that there's probably a cloud of trillions of asteroids, hundreds of trillions of asteroids around the black hole, because it's huge, supermassive. And occasionally, one of them gets close to it, and by close they mean about roughly 150 million kilometres, which is about the distance of the Earth to the Sun.
Oh, it's pretty close. 150.
It is. It is actually pretty close in space terms.
Yeah.
You know, if you looked at it on a diagram, it would be right up there. And so when an asteroid gets closer than that, it gets ripped to pieces by the gravity of the black hole, and then vaporized, giving off all this energy.
So vaporized. Okay. So does the black hole absorb that energy, or does it send it back out? What happens to it?
Well, the light that we see, or the X-ray that we see, has been sent out. Otherwise, we wouldn't see it.
Right.
But yeah, whatever's left of the particles. I mean, the black hole's gravity around it would be so strong that it would pretty much rip any matter down to its constituent atoms. So it would be just a whole bunch of atoms would actually cross the event horizon and fall into the black hole. So yeah, most of the mass and therefore energy would be absorbed by the black hole. We'd just see this kind of flare.
And do we know much about what happens inside the black hole after that? We don't, do we?
Well, the short answer is no, not really. No, they go into this wall called the event horizon that nothing can come out of. And just to sort of recap on what that is, that's the limit where there's something. The singularity in the center is so dense, it has so much gravity that even light can't escape.
Yeah.
So the point that light gets to before it stops or turns back or whatever it does, that's called the event horizon. That's the kind of the wall of the black hole that we see. And inside there, no, we've got no idea really, because the speed of light is one of the great constants of modern physics.
Yeah.
E equals mc squared. C stands for speed of light. So when we don't have c as a constant, the laws of physics as we know it kind of break down.
Yeah. So, so is it fairly amazing though that when these asteroids hit this event horizon, that they even give off anything for us to see?
No, in fact, that's one of the main reasons that we know that black holes exist, is sort of seeing what the sort of carnage they cause around them by ripping things to pieces. So, I mean, you can see closer to home examples of things being ripped to pieces when they get near something with too much gravity, like Saturn's rings were probably once a moon that strayed too close to it and just got ripped to pieces. So this is fairly common. The black hole's got much, much more gravity. So when it rips something to pieces, it's much more violent. giving off much more energy in a short space of time. And yeah, the X-ray signature of black holes is one of their big telltale signs, because that's all the material around them being super compressed by that gravity.
So is it?
So it's just.
Yeah, go ahead.
Okay, it's just when things cross the border, cross the event horizon, that they're gone and nothing can get out. But we can see the aftermath of the black hole around it.
So is it true that when you go through the black hole, you get transported to an alien planet?
Absolutely.
Yeah. Good-o. What's going on at the Auckland Stardome this week?
Some good night sky viewing. There's sort of two planets in the same part of the sky. We've got Venus over there in the west, very bright, you can't miss it, just after sunset.
Yep.
And then if you track a little bit up towards the north, you'll find the second brightest object in the sky, which is Jupiter. So two planets there approaching each other. Venus will catch up with Jupiter in probably about a month, I'd say.
Yeah.
So there's some good planet viewing and good sky viewing in general.
Great. And it's still nice and warm at night to go out and spend some time staring at the sky, or the fantastic sunsets like in Auckland last night with the crazy cloud formations. I'm sure most Aucklanders managed to catch that. It was pretty choice.
I saw your photo actually. Yeah, it looked great.
Down, some fish and chips down on the beach, watching the sunset. Really nice night actually. Dylan, thanks very much, and if people want to continue the conversation with you, it's twitter.com/Dylan Storey, and of course thanks very much to the Auckland Stardome. Cheers, Dylan.
Indeed, thanks, Wammo.